Hello everyone, great to see you again. It's been a while. So recently I have been working with a few developers on the MDM side, looking at how the device is installed, reconfigured, removed, those scenarios. And I realize I haven't talked about MDM side um, intensively. I think mainly the C2M is focusing on the CCMB. I did talk about the mapping between CCMB and MDM objects. I also talked about meter reads in one of the videos. Please look at those ones for reference. But I think today it will be great to go from object level, at least the object level on MDM side, see how the objects are related and what are the different scenarios and how do we utilize this object model in different scenarios. Okay, so we'll go through four topics. We'll go through overview and then look at the objects or in related to device. Um, Look at different scenarios and last we will look at the entity relationship. Right, so for CCMB and MDM diagram, this is the mapping between the two part of C2M. Today we will mainly look at the objects on the right hand side which is not mapped to CCMB. But actually in the history of these two products, when CCMB and MDM they are separate products, CCMB do have objects which encapsulate the information um, for this object on the right. So equivalently for say device, CCMB has object called meter. Device config, they have a meter config, and machine component, I think there's an object called register. And for installation events, they would have an object called meter service point history. So this is actually for asset management on CCMB and where meter reads is captured on the register for billing. The the part the role for MDM to come into C2M is MDM is a better product handling half-hourly consumption, and also very flexible in terms of device management, so it can track the history of the device, and it can also be used as a part of asset management. I know in the later products of Oracle Utilities, there is product of called WAM, Work Assets Management, which is essentially based on this data model. Although WAM is adding a lot of functionalities in terms of the uh, uh, SGG, which handling with the smart meter, remote configuration, etc., like that. But back to this CCMB MDM topic, these objects they are not brand new, but they are very important to understand within MDM because all the meter reads is literally stored against measuring components, and so it is important to know how we can manage different metering scenarios, which I will cover in a later stage. Okay, so first of all, let's talk through some terminologies. So I take an example, say a two-rate meter. Um, One is peak, one register measuring peak, and one register measuring off peak. Okay, so the term register and the channel are actually synonyms for measuring components. So measuring components actually captures the register. Okay, so in this case, if it's two rate meter, we will have two measuring components. Okay, and while most devices are meter implementation setup device for every asset implementation sets up device for every asset that measures or monitor resource usage. Okay, so there are different type of objects um, to capture the asset. Okay, in terms of assets, we can categorize that into metered or metered. For metered asset, which normally is just a meter, that will be modeled as a device. But for a metered, normally what we can do is we can model that as item. Now, item is a separate object, but item can also be installed on a service point or linked to a service point. So that's why I was saying it is a comprehensive model to track all the assets for the asset management. Okay. Measuring components measure the same unit of measure. Each measuring MC measuring components measures consumption a different TOU. All measuring components must reference a UMTOU is optional. Okay, so when you define a measuring component, and this is something I think I need to explain a bit. In MDM, most of these objects, so service point, not installation events, but device config, uh, measuring components, all these reference objects, they would have admin objects. So you will see the service point type, device type, device config type, and measuring component type. The type objects actually defines the property of the transaction object. So, for example, for measuring component type, it will actually define what are the units of measure, what is the time of use, what is the SQI, which we'll just talk about that a bit. These three information is the key of measuring component, what actually is it measures. So for example, in this case, the unit of measure will be same because both peak and off peak, they're measuring the kilowatt hour. But the time of use will be different. One is peak and one is off peak. SQI is an additional field to indicate whether, for example, over here you can see it can be used to indicate whether it's a generation or it's a consumption, or normally what we can say, we can use that is to differentiate even it is measuring the same combination of unit of measure and the time of use, you can say you can differentiate just for any reason. Okay, but all of them are actually optional. Okay, and sorry, not all of them are optional. The UOM is mandatory, but time of use and SQI, they are optional. So you don't have to define a value for them for the measuring component type. And um, in most of the cases, it's quite straightforward. So in this case, the kilowatt hour is the unit, and time of use would differentiate between two register, which is measuring component type. But in some of the cases, you would have a different. You will have cases where the time of use is the same. So maybe some of the let's say between let's say a peak usage, right? A peak usage and sorry, let's say a maximum demand. Maximum demand could be different between a quarterly maximum demand, or it can be a measure for a monthly maximum demand. So if you there isn't really a way. So for both max demand, the kilowatt hour, I mean the measure of the unit of measure will be same. It will be kilowatt. Time of use, that doesn't really apply. So in that case, you can use the SQI to say one's monthly and one's quarterly. So in that case, we can have separate measuring component type and indicate what it is actually measuring. So when you define the measuring component type, you need to be extra careful on this combination, because this combination is also used in billing as well, because if this information need to be fed into the rate calculation, the combination of these three will be sent into through the usage transaction into CCMB. Okay, so second part we talk about the device related objects. I put these main objects on one page. Okay, so I think let's start from the last one, service points, which actually is the in terms of hierarchy, it's at the top one. So service points, they are physical locations, usually a mirror socket which a company supply service and used in C2M to store information describing the type of service supplied and how it's measured. Okay, so um, remember on the mapping we have service point mapped to both a combination of premise and service point in CCMB. Now in CCMB, the concept of premise is the location. Okay, so what is the address? And the the service point in CCMB is a logical uh, it's a logical service to I mean a logical point where a service is applied. So it's actually store all those service point level um, attributes. For example, the line loss factor, the MPAN, MPAN identifier, and DNO. In UK, when we have a meter point information, which we call meter point information, the information is stored against service point CCMB. However, in MDM, there is only one object. So the service point in MDM, we have to remember it covers both. So it covers not only the logical information, but also the premise, which is the physical location. Okay, so all the information is literally on service point, one object in MDM. And so we use similar tables, characteristic tables, to store the meter point attributes, and also the in MDM there is a service point identifier table. We use that to store the, for example, MPAN. These identifiers for the service point. Okay, so one level down, that is installation event. So installation event capture the history of device that has been installed at a service point. This allows consumption for a service point to be calculated over time. Installation event link a specific device configuration to a service point. Okay, so the two things I think most important is it keep the history, right? It captured history and it should keep the history with the device linked by the device config. Why that is important? Because a lot of the usage rules would actually look at installation event. So for example, if you are billing for a quarterly bill, Jan, February, and March, and if you have a meter exchange in February, you would actually have two installation events. The old installation events might be removed, and the new installation event might be, it will be installed. So you end up with two installation events during this period. The usage rule would actually pick up both of these and look at different meter with different consumption between these two periods. And this also is one of the source to capture device events. Because device events, let's say some of the device events could be a warning about the usage outage, the network outage. So during a period, if we receive device event, say in the last 10 days, there is one day there is the network has outage. Now in that case, installation event will be able to capture this information. Installation event has a child table called on and off history, and that can be utilized during billing, or it can be utilized during the estimation process as well if required. So it can actually consider to treat that period a bit differently. A second point I want to talk about is the device config. Okay, so remember, installation events link to a device config. It's not linking to a device, because same device actually means it's physical meter. Same device can be reconfigured, and if any meter get reconfigured, it needs to have a separate installation event, which means if you have a meter reconfigured and you create a new meter, a device configuration, a new installation event will be linking it to the service point. And remember, there's one very important thing in MDM. That's a key concept. for one service point at one time, you can only have one device config linked to it. Okay, you can't have two of them active at the same time. Right, so let's go one level down, device configuration. So a device can be reconfigured over time. Each device configuration encapsulates MC. The group of MC are effective on the device configuration effective dates. Yeah. So again, like the example we were talking about, we have this peak and off-peak 2 rate. Then in that case, you have one device configuration with two measuring components. One is peak, one is off-peak. All right. Now, device. Okay, device. I always want to treat device and measuring component as two aspects of a device configuration for some reason. It might be totally wrong. But I would say the device is kind of a physical side of a device configuration. And the measuring component is a logical side or a reference side of device configuration. And the device configuration is actually representing how service point is metered. Okay, so let's just look at the device. Device has different attributes, and they can record um, things like manufacturer model, serial number, batch number. For smart meter, it can be linked to the head end. Not going to talk too much about it, but I think um, the type of device in utility is very important. And one thing needs to understand is because this is kind of hardware side of the device, so device doesn't really have well, device would have a device type, but it doesn't normally have the um, attributes to indicate how the measuring component um, should be included. Because remember, we just talked about the type object. The type object actually defines what is the allowable link between different device types and the device configuration types. So normally when we are saying a smart meter, okay, let's take things easier. Half hourly, half hourly device configure, half hourly um, meter. Okay, so we probably could have a half hourly um, device type. But normally what we do is we would have a half hourly device configuration type. Okay, because the reason for that is for the device configuration type, it can actually indicate what are the different types of measuring component type it can be linked to. So for example, if you have a half hourly device configuration type, that will be able to define what are the allowable measuring component type it links to. So in that case, you can only have interval measuring component type rather than register, unless you have some of the half-hourly meter. You also want to keep the reading as well. But similarly for non-half-hourly device configuration type, you probably won't have interval measuring component type linked to it. So this is why I would say the meter is very, I mean, the service point is very much metered by device configuration itself. Okay, so these type of objects are really important when you are defining them. It's not only defining the overarching information about it, but also it's defining the relationship between different types of different objects. Okay, last one, we talk about the measuring components. So a measuring component may differ from each measuring component on a device. For example, the type of measuring component defines the UM, TOU, SQI we were just talking about. Um, Whether it's scalar interval, if it's interval, what is SPI? SPI is the second per interval. So if you are defining half hourly and you know how much to put there, it's just how many seconds within half hour. Okay, um, and it also defines the channel ID, defines the multiplier because for example for gas, a lot of the meter, especially those turbine meters, the multiplier is not one; it's like hundreds. And obviously for water, I know it has a lot of different type of meter, and the channel will be different. So we can utilize these attributes so the system can calculate um, the consumption correctly. By the way, all these multipliers they will be taken into consideration when the base usage rule are applied. Okay, so the, we need to look at details at when we are designing these um, systems. Value other than one means the system multiplier, the consumption, yeah, derivative usage. That's right. So this is an overview on this object, and I hope it makes sense to you. Okay, so let's look at some scenarios. Now over here, the first I want to talk about is the electricity multi-site. Okay, in UK, for example, if you have a service point, you might just have a single MPN, but you actually have multimeters in the on this MPAN. Okay, so we call it multi-site scenario. And in those cases, because you only have one uh, MPAN, so you have to define a top level service point. Otherwise, you're gonna have say two different service points on the same MPAN, which is very confusing. So what we normally do is we have master and the child service point, and they are actually linked by the service point relationship table. And for each of service points, we'll have installation events, device configuration components. Okay. Now, second, for meter reconfiguration, which doesn't mean a meter has been removed. Now, in this case, we have a master service point and we only have one child service point because over time, the meter has been reconfigured, but it's not been I mean the device. Well, I mean my diagram has some. It's not that clear, but literally these two devices is one object. Okay, so it's the same device, but it's gonna have two different device configuration. Obviously, if you have two different device configuration, you're gonna have different measuring components as well. And one of them will be in a removed status, with a removal date, and another one will be in active status with installation date, and they normally doesn't contradict each other. Remember, we can only have one active installation on the same service point. Right, last one. So in UK there are a lot of emitter sites, which we don't have a meter for it. So where do you actually keep the consumption for it if you don't have a device? Now in those cases you normally don't create a device, and if you don't have a device, you don't have a device config. You don't install it against service point. What you can still do is you can create a meshing component and link that to the service point via either characteristics or some other way. Okay, so normally what we do is we link that through characteristic. So you know for when the billing is running, it will check what type of meter, what type of service point it is. If it's a meter, it will look for all the machine components, have a characteristic linked to the service point, and in that case, it will just be able to find out the consumptions about this service point. Okay, let's look at entity relationship. Um, so here is the five main objects we talked about today. So service point, installation event, device config, and machine component. A lot of the child tables, and for the child tables, I think a few of them we already talked about. So for service points, you would have characteristics, you have the SPGO location, which store MPAN information, and installation events would have a log on and off history, which keeps track of whether the device is on and off um, for the for various purpose. We can actually monitor these history to understand, what has been happening, or maybe there is a meter tampering activity. So these information are important to keep record. And for device config, we can have device linked to it, where device have different identifiers, and device also can keep the information like manufacturer on the device object, and the measuring component, again, that is a very key object because it holds the meter readings and also consumptions, depending on what type of it is, and that is linked to device config. Okay, hopefully that give you some idea on how the MDM objects works together. Any questions? Let me know. Thank you. Bye.